All right, welcome back. Thanks for being here. We're in 6.7, which is solving radical equations. So let's dive into it. The very first thing that we would talk about is where my pen is. There we go. So the principle of powers. The principle of power says that if A is equal to B, then A to any power is equal to B to that same power. Which makes sense, right? If you have something that's equal, if you raise it to the third, raise the other side to the third, they should still be equal, right? So we use that to solve equations that look like this, right? I can isolate the square root of x here by adding 3 by using the addition principle. And so I have the square root of x now is equal to 7. And I have this part. I have an equality. Something is equal to something. That is to say, then, if I square both sides, I still maintain that equality. This square cancels out that x, or the square root, right? And I get x equals 7 squared is 49. And this is primarily why we started saying we don't really care about whether or not x can be positive or negative, whether or not the square root of the square ends up being the absolute value of x. What we really care about is when I square this thing and get rid of that, and I'm going to square the other side, is it still going to end up as a positive number? It typically is, and therefore we don't typically have to be as careful as to say, well, this is going to end up as being the absolute value of x. It doesn't matter, right? So let's take a look at perhaps another one. Let's say I've got the square root of x plus 5 equals 3. So again, I'm going to solve for the square root of x. I'm going to isolate that square root of x. I'll do that by subtracting 5, again using that addition principle of equalities. The 5 cancels out and isolates the square root of x, and now it's equal to -2, right? And again, this is why we don't have to concern ourselves with, oh, if I square this thing, you know, whether or not my x could be positive or negative. This equation simply doesn't have a solution. And it doesn't exist because this is the principal square root of whatever that value is, right? And therefore, I can't get a negative out of it, right? And so I have no solution. So if you end up with the square root of x equals some negative number, not going to happen, done, that's it. That's the end of that story. Right? If you kept going, you would end up just simply with a false value. So if I said, oh, I've got the square root of x equals -2, and I come in here and square everything, it's very easy to get to this point and say, oh, well, x has to be equal to 4, and convince yourself that you're right. But if you try it into the solution, or you try your solution into the equation to check it, that tells you then that the square root of 4 plus 5 should be equal to 3. But the square root of 4 is 2, and 2 plus 5 is 7, and this is false, right? So you can still square it and then solve the result of that, but you cannot say that it's valid, right? Once you've gotten that negative in here, that's the end of the road. Okay, let's look at a little bit more complicated of one. I still want to solve for x, and I have x equals the square root of x plus 7, and then plus 5. So the idea here was to isolate the radical, that x, the square root of x plus 7, I want to get that all by itself. So I'll continue with that plan. I'm going to subtract 5 from both sides. That gives me x minus 5 on one side is equal to the square root of x plus 7 on the other. And I'll square both sides again. I square primarily to get rid of that square root, but I have to square both sides. If I square one side, I square both sides. And so I have to FOIL out x minus 5 and x minus 5. So I'll do that off to the side if you like. That's x times x is x squared minus 5x minus another 5x. Minus 5x there, minus 5x there, and then plus 25. So that simplifies to x squared plus 10 minus 10x, and then plus 25. On the right-hand side, that's just x plus 7, because that just breaks it out of the square root. It's a second degree, it's a quadratic, so I want to pull everything to one side. So I'm going to subtract x, and I'm going to subtract 7 from both sides. This gives me x squared minus 11x plus 18 equals 0. I've got it set equal to 0. It's a quadratic, so I can use the factor and the zero factor theorem if I can factor 18, or if I can factor the expression on the left-hand side here. So 18 factor pairs are 1 and 18, 2 and 9, and if I let them both be negative, those are my guys. So this turns into x minus 2 times x minus 9 equals 0. And if I set these individually equal to 0, then I have x equals 2 or x equals 9. And I'm done. And I can check those both, right? Plug them both in, see if they both work. They should both work. So I'm going to check first 2. If I plug 2 in, I get 2 equals the square root of 2 plus 7. And then plus 5, right? Or 2 equals the square root of 9 plus 5. The square root of 9, though, is 3. Oops, not a square root anymore. And that is not true, right? So this guy is false. And that takes 2 out of the possibilities for solutions, right? But I will check the other one. Let's check 9. That would mean then 9 is equal to the square root of 9 plus 7 plus 5. Or 9 equals the square root of 16 plus 5. The square root of 16, of course, is 4, and this one works out. So I do have one solution. It's x equals 9. But why did we end up with that solution there? And the answer is because we squared, right? When we square something, we add in a potential incorrect solution. And because when you square something, you eliminate negatives. It's kind of a weird, convoluted thing. But just know that whenever you have to square something to solve, every single time you should check your answers, because more likely than not, you've introduced a false solution into your work, right? So check, always check your answers, right? Okay. Let's look at another one. Where is my mouse? This one is pretty ugly. But here we go. All right, I want to solve this for when the square root of one expression, x plus 5, minus the square root of another expression, x minus 7, is equal to 2. And so I can't isolate a square root by itself without having another square root, right? There's no way to isolate these square roots both, right? So what I'm going to do is I'm going to add the square root of x minus 7, add the square root of x minus 7, and I'll just isolate one of these guys. So x plus 5 is equal to 2 plus the square root of x minus 7. And I'll square both sides, because if I square both sides, I'm freeing up this square root gets canceled out. But on the other side here, I have a binomial, really. I have the 2 plus the square root function expression all squared. So what I've really done is I've turned this into x plus 5 is equal to that 2 plus the square root of x minus 7 multiplied by another 2 plus the square root of x minus 7. And I'm going to FOIL this together. So I get 2 times 2 is 4. I get a 2 times the square root of x minus 7. And then I get another 2 times the square root of x minus 7. And then that last term is the square root of x minus 7 multiplied by another square root of x minus 7. That just becomes x minus 7. And so what I've done now is I only have one square root term, right? Once I combine these two of the same root, now I only have one square root term. So I have to, let's clean it up a little bit. We'll say this is x plus 5 still, equals, I've got 4 and I've got minus 7. So that's minus 3. I've got 2 roots of x minus 7 and 2 more, so that's plus 4 roots of x minus 7. And then I've got this plus x. But now I just have one square root, right? That x minus 7. I want to isolate that. So I'm going to add 3 to both sides to get everything that's not part of that root out of there. Minus x from both sides. And that's nice. That x cancels out. The x's cancel out. I've got 8 equals 4 times the square root of x minus 7. Because they're both divisible by 4, I'm going to divide that out. Divide each side by 4. Divide each side by 4. The 4 cancels, and that leaves me with 2 equals the square root of x minus 7. I've isolated my last square root, and so I will square this guy and square that guy. That leaves me with 4 equals x minus 7. And to solve completely, I'll add 7. That gives me x equals 11. And that should work, but I do need to check it. Always check, even if you just get one solution, check that. So let's plug it in to the, where was the original equation? Up here. Let me get like a green or something here. So I'm going to plug it into this square root of x plus 5 Well, x was 11, so 11 plus 5 under a square root is equal to 2 plus the square root of 11 minus 7. 11 plus 5 is 16, so that's the square root of 16, which is 4. Should equal 2 plus the square root of 4. But that's 2, and it works. 4 equals 4. It checks out. That's our solution. X equals 11. And it looks like that's it for that one. That was also a shorter one. Dense in material of difficulty, but that's it. Thanks. Bye.